Hi, my name's Blake, and I'm in a group with Brendan, Callis, and Callum. So we're going to be talking about Chinese mathematics. So with the mathematical orders we use today, does the Chinese mathematics methods still hold, and are they still relevant? Using among various mathematical calculations, the Pascal's triangle, developed by Blaise Pascal during his experimentation during 1647 to 48. However, the Chinese already using this method 300 years prior to Pascal's work. In 1303 AD, a Chinese mathematician Xu wrote a major influential text, Precise Mirror of the Four Elements. Included in this text was an early Chinese version of the Pascal's triangle. It is believed that this triangle had been used for at least 200 years prior to Xu. During the Sui and Shang dynasties, mathematics in China was taught at the Imperial Academy, later known as the 10 mathematical classics, with 2 being very important to the modern maths calculation. The shadow gauge was thought to be around 100 BC to 100 AD, for measuring the positions of the stars or the sun using shadow gauges. This was carried out through one or more of these gauges, forming squares and triangles of known area, whereas the C manual from 263 AD, much like the shadow gauges, but performed measurements for the distance for hills, gorges, and valleys. Both of these methods are widely used in today's maths. An early numbering system of small bamboo rods dates back to about 2000 BC. These rods are arranged in simple patterns and even provide decimal placements, and well before the West. Furthermore, this simple method is still used today to provide complex multiplication calculations with a simple, easy-to-learn maths trick. Chinese maths methods are still highly relevant in many parts of our mathematical understanding today, such as Pascal's triangle, decimal notation, and many more. Has the Chinese mathematics evolved into today's methods? Most certainly. Now for a bit of history. The majority of early mathematics belonged to civilizations that nowadays don't exist, such as the Babylonians, ancient Greece, and Mayans. China is one of the few that has survived due to China being an isolated civilization in early ages. The study of mathematics wasn't interrupted by large-scale war as much as what we found in the West. This led to Chinese mathematics discoveries being decades and even in some cases centuries before anywhere else. As with everywhere, war, mainly of the civil nature, did slow down progress in different patches of history, with certain emperors ordering texts and libraries to be burnt. While it is hard to find exact records of when the first big mathematical discoveries were, it has been estimated that some mathematical texts date back as far as 1200 BC. One of the most notable ideas formed in early Chinese mathematics was that of the form of the decimal system, long before anywhere else adopted it. How did discoveries in mathematics influence how mathematicians thought? Before the globalization of the world, Chinese mathematics were hundreds of years ahead of Western world, and in some topics of mathematics. During this time, advances in algebra led to findings long before the Western world discovered the fundamental techniques we use today. The most critical piece of work in Chinese mathematics, called the 9 Chapters of the Mathematical Art, had broad reaching effects since its creation in the 1st century. The work contained 246 problems along with the processes to answer questions, covering a wide variety of topics including agriculture, engineering, and right-angled triangles. Not only did the book provide Chinese people with the skills to mathematically solve a wide variety of problems, but it also altered the mathematical thinking of the broader Eastern world. Introducing mathematics we consider fundamental to today's society. Another key period in Chinese mathematics was in the Sui and Shang empires. One of the most important discoveries to come from Chinese mathematics during these empires was the development of a way to solve higher-order algebraic equations using a method similar to the Horner method. While the mathematics developed at this time was purely for the Chinese calendar and astronomy, solving these questions would provide the fundamental problem-solving skills and techniques for future Chinese discoveries. Thank you for listening.